Hello, Nabal and Nafisa.
Hello, sir.
Hello, sir.
Okay. Um, Today we'll discuss first rules for image formation by convex lens. So this is a convex lens. There are two convex surfaces. This is one convex surface and this is another convex surface. And in our syllabus, the lenses are very thin. What is the meaning of lenses are very thin? So I can make this lens a straight line also like this. This much thin lenses are there in our syllabus. Means we can just say the lens is like this, very thin lens. Okay. So there are certain rules. This is the pole, optical center. This is the optical center. O. O here is optical center. And this line is the principal axis. Principal axis of convex lens. So first rule is if a light ray is passing from the optical center, then it will pass straight. There will be no refraction or no bending. There will be no refraction and no bending will be there. Second rule is this is the pole, optical center. If the ray of light, if a ray of light is parallel to the principal axis, like this, see. This is the principal axis and a ray of light is parallel to the principal axis. This is the principal axis, ray of light parallel to the principal axis. After passing from the lens, after passing from the lens, this ray of light will pass through a point, will be the principal focus of the lens. Principal focus of a convex lens is also the second focus we discussed in the last class. So for the image formation, there is a requirement of only two rules. Image formation by convex lens. There is one more rule, but we will not use that. If a ray of light, so here is F1, first focus of this convex lens, principal axis. If a ray of light is passing from first focus like this, and if this ray of light after passing from the first focus is entering to the lens, then the ray of light after refraction from the lens becomes parallel to the principal axis. A ray of light passing from the first focus of the lens after striking the lens becomes parallel to, means after passing through the lens becomes parallel to the principal axis. through the principal axis. So these are the three rules. Basically, for the image formation by the convex lens, we will use this rule, rule number 1 and rule number 2. Mostly we will use these two rules. Okay. So one by one we will discuss the image formation. Okay. This point is the optical center O, and here is the F1, means the first focus, and here is the second focus, F2 of this lens. And the distance between O and F1 is focal length, and the distance between O and F2 is also the focal length. Now here is another 2F1. Now what is the meaning of 2F1? This distance means distance between F1 and 2F1 is same as distance between optical center and F1. And here also you can write 2F2. Here is 2F2. 2F2 means this distance and this distance is equal. Okay. So I'm taking case number 1. When object is placed beyond 2F1, object placed beyond 2F1 means the object is here, like this somewhere, and we will see where the image will form. So this is the object beyond 2F. Object is there. Now we will draw the ray diagram. So this is the object. So for the image formation of this object, there is a requirement of two rays from the object. At least there should be two rays meet at a point. So suppose first ray from this object is parallel to the principal axis, like this, parallel to the principal axis, and we know that so if a ray of light is parallel to the principal axis of a convex lens. For ray of light is parallel to the principal axis of a convex lens. After refraction, it will pass from the F2. So it will pass from F2. This ray of light will pass from F2. Like this. Now another ray from the object is suppose passing from the optical center and meeting like this. And I told you that whenever a ray of light passes from the optical center of the lens, the ray will not deviate it. So both the refracted rays are meeting at some point here. So here the image will form. Here the image of the object will form. So this will be the image. This will be the image I. Okay, so you can see the size of the object is greater than the size of the image, and here the rays are actually meeting, then the image will be real. And see the direction of arrows, both are opposite, so image is inverted also. So you can write the characteristics of image. Image is number 1. Where the image is formed? Between F2 and 2F2. This image is forming between F2 and 2F2. So you will write image is formed F2 and 2F2. Second point. This image is real and inverted also. So image is real and inverted. Why real? Because rays are actually meeting. Why inverted? Because real images are always inverted. And so you can see the direction of arrows. The object is above principal axis and the image is below principal axis. That is why the image is inverted. Third, you can say size of the image is less than the size of the object. So you will say the image is diminished. Okay. So in this way you will draw the ray diagram. So another case number 2. So in case number 2, we will place the object at 2F1. Earlier the object is here. Now we will place this object here, and then we will see where the image will form. So now I am placing the object at 2F1. This is the object now at 2F1 this time. So from this object, suppose one ray of light is parallel to the principal axis like this, and after refraction it will pass from the F2. It will pass from F2. Another ray of light from this object is like this, passing from the optical center, and it will pass like this, pass straight. Now see where both the refracted rays are meeting. Here, these rays are meeting. So this will be the image at 2f2. And this image will also inverted and real. But this time the size of the image and size of the object is same. The size of the object will remain same. The size of the image and the object will become same. So to draw the ray diagram, at least two rays, the object means there is a requirement of at least two rays. So first ray from this object is parallel to the principal axis like this, and whenever a ray of light parallel to the principal axis of a convex lens, it will pass from the focus like this after refraction from the lens. If a ray of light is passing from the optical center, so there will be no refraction, or you can say there will be no bending. So this ray will pass straight like this. So you can say now about the characteristics of image. Number one, image is forming at 2f2. Now point number second, the size of the image and the object is same. So you can say same size. Of object. Another point, rays are actually meeting. So image will be real, and see the direction of arrows, image is inverted also. So image is real and inverted. Real and inverted. So this is the case when object is at 2f1. This is the case when object is at 2f1. Now case number third. This object is now 2f1. Now we will place the object between f1 and 2f1. So this object will place, earlier it was at 2f1, now we are placing this object here. We will draw the ray diagram again. So first ray of light from this object is parallel to the principal axis like this, and after refraction from the lens it will pass from f2. It will pass from f2. Another ray of light from this lens is like this. Means passing from the optical center. Now you can see both the rays are meeting here. Both rays are meeting here at this point. So here the image will form. So this is the image this time beyond 2f2. If the object is in between f1 and 2f1, the image is forming beyond 2f2. Okay, and this image will be real and inverted also. This image will be real and inverted also. And what about the size of the image? You can see size of the image is greater than the size of the object. So we can write the characteristics of image. Image is number 1, formed beyond 2f2. Okay, formed beyond 2f2. Number 2, real and inverted. This time the size of the image is greater than the size of the object. So enlarged, image is enlarged. Enlarged means the size of the image is greater as compared to the size of object. Matthew, Nafisa, and Nawal, are you getting?
Yes, sir.
Yes, sir.
Okay. Okay, please first copy these rules or take the screenshot. Scroll down.
Sure, sir.
Okay. Okay, take the screenshot of this. So here the object is placed beyond the 2f1 and image is formed between f2 and 2f2. So this is the case number third when the object is in between f1 and 2f1. Okay, when object is in between f1 and 2f1 and you are getting the image beyond f2 2f2. Take the screenshot. After this, case number uh, fourth. Case number fourth. Case number fourth. When the object is placed at f1, at f1 means here. F1. So this is our object and we are placing this object at f1 and we will see where the image is formed and how the image is formed and what are the what will be the characteristics of this of the image formed when you are placing the object at f1 or the first focus. This is the first focus of this lens. So we will draw the ray diagram. So first ray from the object is parallel to the principal axis, and if a ray of light is parallel to the principal axis of a convex lens, after passing from the convex lens, it passes from F2 or focus. Okay. Now another ray from this object is like this. Another ray from the object is passing from optical center. Is passing from optical center, and whenever a ray of light is passing from a optical center, it pass straight. Now you can see both the rays after refraction are parallel. These rays are parallel rays. And where parallel rays meet? At infinite. So parallel rays meet at infinite. Okay. So where the rays will meet, there will be the image. So image will formed at infinite, and the size of the image is very large as compared to the size of the object, and obviously the image is inverted. So you can write image is number one formed at infinity, infinite. This is how we represent infinite. Number second, real and inverted. Number third, what can you say about the image? Very large than object. Size of the image is much larger than the object. So highly magnified, you can say. Highly magnified, or you can say very larger than the object. So when you are placing the object at F1, the image is formed at infinity. Now case number fifth. Now we will place the object between optical center and focus. First we have placed the object beyond 2F, then we place the object at 2F, then we place the object between 2F1 and F1, then we place the object at F1. Now we are placing the object in between optical center and F1, and different types of images we are getting. So this is the object this time, and this object is in between optical center and F1. Now from this object, first ray is like this, suppose, parallel to the principal axis. And if this ray of light is parallel to the principal axis, it will pass from F2. Another ray from the object is like this. Another ray from this object is passing from the optical center like this. And whenever a ray of light is passing from the optical center, it passes straight. Now you can see here both rays are getting diverged. and diverging rays will never meet in actual. So what we will do for the image formation, we will just produce these rays in the backward direction like this. So you can say the image will form somewhere here. What you have done, you have just produced these rays in the backward direction. In actual, these rays are getting diverged and will never meet in, okay, never meet. But you are producing these rays, these diverging rays or refracted rays in the backward direction, and here these rays are just appearing to meet, and here will be the image. This will be the image. This will be the image. So this time rays are not actually meeting. Here in this case, these rays are actually meeting at infinite. These rays are actually meeting here. These rays are actually meeting here. These rays are actually meeting here in this case. But in this case, these rays are not actually meeting. These rays are just appearing to meet at some point. So here this image will be virtual image. This image will be virtual, not real. So image is number one, where the image is formed. Here, where the image is formed on the same size of the same side of the object. The object is on the left hand side of the lens. Image this time is also on the left hand side of lens. Here you can see in this case, or earlier cases we have seen that object is on the left hand side or the right side of the lens. So here the image is formed on same side of object. Number second, this image is virtual and erect. You can see this is the erect image. So virtual and erect image. Virtual and erect. Number third, what about the size of the image? Size of the image is greater than the size of the object. So you can write image will be magnified or enlarged. Magnified or enlarged. Magnified or enlarged. Okay, take the screenshots. Done, Matthew, Nawal, and Afisa?
Yes.
Yes, sir. Yes, sir.
Okay. Just wait a minute. This is the case number fourth, and this is the case number fifth. Case fifth. In this case, the object is in between F1 and optical center. F1 and O means F1 and optical center. Now you can take the screenshot. Okay, now after this, we will see when this object will be at infinity. When the object will be at infinity, in that case, we will see where the image will form. And I told you many times that whenever an object is at infinity, so from that object, the rays are parallel. From that object, the rays are parallel. So case number sixth, you can say. Case sixth. When object at infinity so if the object will be at infinity, then there will be the parallel rays from that object. So this is suppose first parallel ray from the object at infinity. This time the object is infinity. That is why the rays are parallel. All the rays are parallel from that object. So I am taking only two rays. So these two rays are from the object. These two rays from the object at infinity. These are the parallel rays. And where parallel rays in case of the convex lens meet at focus. So these rays will meet at focus. So image will also formed at focus. So these rays will meet at focus like this. And you can see here this point sized means very small size image will form. So now here na, after the converging means after the refraction from this lens or these rays are getting converged at f2. These rays are meeting actually na at f2. So this image will be real. And I told you if the image is real, I told you say it is also inverted. Okay. Another point. What can we say about the image? Another point. the size of the image is very much larger, very much smaller than the object. And where the image is formed? At focus. Where the image is formed? At focus. So in this case, image is number 1. Formed at focus, or F2, or principal focus. Formed at F2. Number 2, what can you say about the image? Image will be real and inverted. Real and inverted. Why the real and inverted? Because the rays are actually meeting. The rays are actually meeting, and I want to explain this like this. See, first the object is here. The image is inverted, and between F2 and 2F2 the image is, okay. Then you placed the object here at 2F1. Again the image is inverted, but now the image is now the image is formed at 2F2. Again you shifted the object towards the lens, means between 2F1 and F1, and image is again shifted here, and here you are getting the image. Again inverted image you are getting. So you can see here, if you are just shifting the object in this direction, if you are shifting the object like this toward the lens, image is also shifting like this. This image is also shifting, and this image is inverted also. So object is shifted here and image is also shifted. So you have shifted the object here, image is shifted beyond F2. So here the image is inverted also. And when you place finally the object at F1, the image is shifted to infinity. And here also the image will be inverted. So on the basis of that, you can say this point size image will be inverted image. If the image is formed that is point size, so I cannot say this image is erect or not. Okay, I cannot say this image is erect or inverted. Why? Because this is a point size image. So for a point, there is no concept like inverted or erect. That is for the linear object, or you can say that is for a finite size object. On the basis of previous observations, we can say this image at focus is inverted. Or you can just remember, if the image is real, then it will be inverted also. Now point number 3. This image is very small. This is a point size image, okay, and very, very small. Point size image. This point size image is also known as highly diminished. Highly diminished. Matthew, have you taken the screenshot of this?
Yes, sir.
Okay. So these are the ray diagrams for the image formation by the convex lens. So sometimes the convex lens means most of the times the convex lens produces a real and inverted image. But there is one case where the image is virtual and erect. That is this case. When you are placing the object in between F1 and O, then you will get the virtual image. Okay, so you can take the screenshot now. The list of this last case. Done? Matthew, Nafisa,
Yes, sir.
Abal. Okay.
Yes, sir.
Okay. Now we will see rules for the image formation by the concave lens. By the concave lens. Earlier we have seen rules for the image formation by the convex lens. So in case of the convex lens, if a ray of light is passing from the optical center, it will pass straight. If a ray of light is parallel to the principal axis, after passing through the lens, it will pass from the focus. If a ray of light is passing from F1 and after that it will pass from the focus lens, it will become parallel to the principal axis. Okay. So we'll see rules for the image formation by concave lens. So this is the concave lens, thin in the middle, thick at the edges, and this is the principal axis. This is principal axis. And here is pole. Here is optical center. So first rule for this concave lens is whenever a ray of light is passing from the optical center, it will pass straight. Another rule, if a ray of light is parallel to the concave lens, then after refraction it will get diverged. Diverged like this, because this is a diverging lens, and when you will produce this diverging rays in the backward direction, so this diverging rays will pass through the principal focus of the lens. That is F2. Okay, rule number third. If a ray of light is going towards the F1, going towards F1, suppose the ray of light is like this, going towards F1. After passing from the lens, it will become parallel to the principal axis. So if a ray of light is passing from the optical center of a concave lens, then it will pass straight. If a ray of light is parallel to the principal axis of a concave lens, after passing through the lens, it will diverge. The ray will get diverged, and if you will produce that diverged ray in the backward direction, that ray will appear to pass from F2. And if a ray of light is just passing, just going towards F1, okay, then it will become parallel to the principal axis. It will become parallel to the principal axis. So in this case, in case of the concave lens, here will be F1 and here will be F2. Here will be 2F1. Here will be F2. Here will be 2F2. F1, 2F1, F2, 2F2. So this is the optical center. So remember, this distance between the optical center and F2 is same as that of the distance between F2 and 2F2. Same is the case for F1 and 2F1. Means the distance between the optical center and F1 is same as the distance between the F1 and 2F1. Now we'll see the image formation by the concave lens. Okay, first write down or take the screenshot of this. So now we will see the image formation by the concave lens. This is the concave lens. This is f1. This is 2f1. This is f2. This is 2f2. In this case, uh, means in case of the image formation by concave lens, there are only two cases. There are only two cases. So case number one, when the object is between infinity and the lens, means you can say object at any position except infinity. Object at any position except infinity. So you can place the object anywhere, okay? You can place the object anywhere. So I am placing the object here. This is the object. And for the image formation, what I will do? Same thing I will do. First ray from this object is parallel to the principal axis. After passing from the lens, the ray will get diverged like this. And when you will produce this diverged rays in the backward direction, it will meet to the focus. This is the object. From this object, the first ray is parallel to the principal axis. Parallel to the principal axis. After passing from the lens, it is getting diverged like this. And when you will produce this diverged rays in the backward direction, so it will appear that it is coming from F2, or it will appear to pass from F2. See, see. And another ray from the object will be like this, passing from the optical center. Passing from the optical center. Now you can see both the rays are just appearing to meet here. In actual, these rays are getting diverged, but these rays are appearing to meet at this point. So where will be the image? Image will be this. This is your object. This is your object. This is your image. So what we can say about the image? The image is formed virtual because rays are not actually meeting. Okay. And image is erect also. And the size of the image is smaller than the object. You can write image is number one formed same side of object. Second point, can write image is virtual and erect. Another point, Size of the image is smaller than the object. Size of the image is smaller than the object. So image is smaller than object. This is the first case, and the second and the last case of the concave lens. Case number second. This is the case of object at any position except infinity. Now we will discuss when the object will be at infinity, what will happen. Object at infinity. Object at infinity. So this is a concave lens. Now object at infinity means rays from that object are parallel, like this. Parallel rays from the object at infinity. These are the parallel rays. Now this concave lens is a diverging lens, so these rays after refraction will get diverged from the lens. Like this. So you can see here the ray of these rays are parallel to these rays are from the object at infinity, because these are parallel. These parallel rays are getting diverged, and when you will producing these diverging rays in the backward direction, these rays are meeting at f2, means the image is formed at f2. So at f2 the image is formed, and this image is a virtual image because these rays are just appearing to meet. So you can say image is number one uh, formed at f2. F2 means principal focus of concave lens. F2 means principal focus of concave lens. And image is virtual and erect. Virtual and erect. Number third, the size of the image is very small. Point size image you are getting. Or you can say highly diminished. Okay. Now you can take the screenshot.
Done.
Okay.
Yes, sir. Yes, sir, done.
Okay. So you can see for a concave lens, always the image is smaller than the object, and there are only two cases uh, for the concave lens. So the image is smaller than the object here also. Here also the image is smaller than, means here the image is even very smaller than object. And or you can see here the image is virtual and erect. Here also the image is virtual and erect. So you can say concave lens will produce always virtual, erect, diminished image. You can say concave lens will produce always will produce virtual, erect or upright also. For erect you can say it is upright. Concave lens will produce virtual, erect, or upright. And diminished image. Diminished image. In case of convex lens, you can see in case of convex lens, there are real and inverted images. Real and inverted, real and inverted, real and inverted, virtual and erect. Means concave lens can produce virtual and erect. Convex lens can produce virtual and erect image, and also the real and inverted image. You can see the size of the image, highly magnified. Uh, Here also the magnified. Here the same size as the object. Is smaller than the object also. So the convex lens can produce a variety of images. Like in case of the convex lens, uh, it can produce the virtual and erect image also for the one case, and the real and inverted image also. Okay, real and inverted image also. And in terms of size, we can say the convex lens can produce the diminished image, can produce the image of same size as object, can produce the enlarged image. But in case of the convex lens, but in case of the concave lens, the image will always virtual and erect and diminished. Okay. In case of the concave lens, the image will always be virtual, erect, and diminished. So concave lens will produce virtual, erect, and diminished image. So add here will always produce virtual, erect, upright, and diminished image. So anyone of you have any doubt, you can ask me. Matthew, Nabal, Nafisa. Ray diagram. If suppose in examination you have to draw the ray diagram, then take the scale there, means with the help of a scale draw the ray diagram. Okay, so this is the case, means object in between F1 and O. When you are placing the object in between uh, optical center and F1, this is the object, huh? Then you are getting the image, virtual image, and that is on the same side as object.
Behind the object, right?
No, you can say that behind the object also, but it is better to say on the same side of object.
Okay, sir.
But in this case, means in the other cases, the image is and means the image is on the right side and object is on the left side. They are not on the same side.